What if your AI could do math for you, but only when it actually needs to? You'll see how to create a simple calculator toolset that language models can call on demand. We'll define 3 basic arithmetic operations, then bind them to an LLM so it can choose which tool to use based on the user's request. From LangGraph, Tools Import Tool. Hash define tools. At tool. Def multiply a int b, int. Multiply a and b. Args. A first int. B second int. Return a asterisk b. At tool. Def add a int b, int. Adds o and b. Args. A first int. B second int. Return a plus b. At tool. Def divide a int b, int float. Divide o and b. Args. A first int. B second int. Return a slash b. Hash augment the LLM with tools. Tools equals add, multiply, divide. Tools by name equals tool name. Tool for tool in tools. LLM with tools equals LLM. Bind tools, tools. This demonstrates the tool augmentation pattern for language models, where Python functions become AI callable utilities through simple decorators. The concept transforms ordinary functions into structured tools that an LLM can discover, invoke, and reason about, creating a bridge between natural language requests and deterministic code execution. What makes this distinctive is how it maintains clean separation between tool implementation and AI integration, with no framework-specific modifications to your core logic. The pattern works by treating decorated functions as self-describing capabilities. Each tool's docstring and type hints become the interface contract, while the decorator handles registration and schema generation automatically. This declarative approach means your code stays focused on business logic, while the LLM gains a typed, introspectable toolset that it can chain together for complex operations without hard-coded workflows. This matters because it solves the last-mile problem of connecting AI reasoning to real-world actions. Instead of building rigid pipelines or custom APIs, you expose existing functions as tools, letting the LLM dynamically compose solutions. The trade-off is trust. You're delegating control flow to the AI, so tool design must account for edge cases and validation that would normally be handled by explicit workflow code. Use this when you need flexible, composable actions rather than predetermined sequences. Let's break it down. From LangGraph, Tools Import Tool. This code defines 3 callable tools: add, multiply, divide, using Lang chains at tool decorator, which auto-generates open API-compatible schemas from the function signatures and docstrings. The tools are then grouped into a list and bound to an LLM via bind tools, enabling the model to invoke them as external functions during execution. At tool. Def multiply a int b, int. Multiply a and b. Args. A first int. B second int. Return a asterisk b. At tool. Def add a int b, int. Adds o and b. Args. A first int. B second int. These are Lang chain tool definitions using the @tool decorator. Each function becomes an AI callable operation with type hints and docstrings defining the schema. The pattern standardizes tool interfaces for consistent AI interaction. At tool. Def divide a int b, int float. Divide o and b. Args. A first int. B second int. Return a slash b. This defines the divide tool using the @tool decorator, exposing it to the LLM for arithmetic operations. The float return type ensures proper handling of division results, unlike integer division. This completes the basic arithmetic toolset alongside add and multiply. Tools equals add, multiply, divide. Tools by name equals tool name, tool for tool in tools. Creates a list of tool functions and a name-to-tool mapping. The list registers all available tools with the LLM, while the dictionary enables lookup by tool name for direct invocation. This dual structure supports both batch registration and individual tool access. LangGraph tool integration pattern. The @tool decorator transforms Python functions into AI callable operations, while bind tools connects them to an LLM for dynamic execution decisions. Tool names in the dictionary must exactly match the decorated function names, or the LLM will fail to dispatch calls. This pattern creates a clean separation between business logic and AI orchestration, enabling scalable tool ecosystems.
The decorator that names nothing becomes the name of all things.